Today we're going to look at SQL Server along with system health and the deadlock and LLMs to analyze those deadlocks. So let's start at the beginning. SQL Server since 2016 has had the ability to analyze deadlocks simply because it captures them by default. This is a feature that previously, or prior to 2016, you had to manually go and turn on, which was kind of an annoyance, honestly, particularly for those of us who used to spend a lot of time looking for these kind of things, and I had to basically turn it on post-event, wait for the next one to occur. Really not fun. So the fact that we can now find them as they happen is a big thing. Now I'm going to go ahead and deliberately create a deadlock here on my test table. The purpose of this is to generally create an example that we can use, because if I check my system health, it didn't have a deadlock, and therefore we would just get an empty table. Now, as you can see, my process here was selected for a deadlock, while one of the processes was successful, meaning that one of the two processes got killed and declared a victim. Now, under normal circumstances, this might happen inside your application and you wouldn't see it. So now we're going to go ahead and check the system health and try to find that deadlock. So this is something that you need to keep in mind when checking the system health, is it's not immediate. So the output is actually a little later, and therefore you can see here my first run as an example is empty. But if you give it like 30 seconds to a minute afterwards, you can comfortably find the output. Now normally when you're in an investigation process, you're connecting to the machine literally a couple of minutes later, so that's not really a problem. Here we can now see the deadlock output, which is in XML format. It's good, but it's not great in terms of it's not humanly readable under the normal circumstances. You can find the victim process. You can also go ahead and find the cause of it potentially in this information. It just takes a lot of difficult and heavy reading. So XML is not a great humanly readable format. It was designed primarily for exchange between systems. Therefore, what we're going to do is take that XML and try to make it a little bit more readable with the LLM. So in this case, I'm going to take the output and I'm going to throw it over to the LLM and say, basically, give me a report based on this. So my first thought was easy. I'll just run the same query that we did in SQL Management Studio, capture that with an invoke SQL, and then throw it over to the LLM with a REST command. Simple enough process. Now I'm going to show you what happened when I tried that the first time. It was not the outcome that I'd hoped for, shall we say. So here I've created the query. I'm going to use my invoke SQL CMD, and at first glance all looks good. I've got my two columns, I've got my output. I'm just going to go ahead and check my XDL file output, and the start is fine because we see deadlock, but the end part of the XML does not end with deadlock, which tells me it got cut off short. Now probably I could fix this, but I just figured, why would I bother spending my time trying to fix invoke SQL CMD when I can just use a SQL client? And I've kind of become a big fan of the SQL client, particularly the .NET library, simply because it's faster. To be perfectly honest, it is way faster, and the results are far more consistent. So here as an example, we see the same output, but if we go ahead and check that column, we'll instantly see that there is more content, and it does in fact end where we expect it to end. So this is why I've kind of given up on invoke SQL CMD, I just see too many inconsistencies in it. So I default to that SQL client now by default. So now we're going to go ahead and create a body for our web request. So our web method here is going to have a body text, which you can see is made up of a prompt, some information about which model we're querying, and we're going with streaming false. The streaming false means that we'll just get a full response instead of a token by token response, which is not particularly readable. Now I'm going to use the LLM that's on my network, therefore it's available to me. For others, you might be using ChatGPT or Copilot or others out there, and that will necessitate the need for an API key if they're publicly accessible. Since I'm using Ollama locally, I don't need an API key. I just point it to the REST endpoint and I'll get a response. Now it's generating the response at this point, and we can now go ahead and look at the response. And what we can see here is we have more information than we want, because we've also got things like token, time taken, and other parts. We also do have the output that I'm looking for, but I kind of want to clean this up because I don't want to view the other stuff that's not important to me. So I'm just going to get the response within the response, and now I have that lovely clean text explaining to me what went wrong, how it went wrong, and potentially even possibly how to solve it. Now this is not as practical in my example because it's just a simple deadlock created to demonstrate deadlocks, but in real world applications this can be a lifesaver because you can spend hours trying to work out exactly what happened, particularly if there are multiple processes involved, and this kind of just does it immediately for you. And that's my tip of the day.